All right, let's get started. Today's topic is bandwidth-friendly tips and tricks. So I don't think we've ever done one like this, so it was new and it's kind of fun. So before we dive into all these tips and tricks, let's talk about why we should care. Hopefully, being that we're in this field, we should know this, but sometimes it's a good recap. So bandwidth isn't free. I think sometimes we think it is because in our situation, it kind of feels that way, right? But especially for a global organization, when we're worried about all ends of the earth potentially, there are places where it really, really matters. There's this really interesting site. It's called whatdoesmysitecost.com. You can go to that URL or that website. You can put it in a URL. It'll download that. It'll tell you how much it costs people to download just that one page, right? And the first chart is in terms of their income, a percentage of their daily income, right? And the second chart is just roughly. So these are places where they're paying per kilobyte, right? And so in places, it's one page load is half of a percentage of their daily income, right? So navigating around a site like YouTube probably is not something that they're gonna do. Another consideration is the varying speeds that people have. So this is a source from Fast Metrics. It's from 2015, so I don't know how up to date it is, but it still should paint a pretty good picture. Apparently in South Korea they have really fast internet. So if you're on a road trip or whatever, too bad. We're about 14.2 on average megabits per second. The global average is 5.6, and then you get into places, I think right now really Africa is probably the slowest region as far as what capabilities are available there. So if you consider that, and you pair that with something like performance or user experience metrics, right? The varying the bandwidth speeds available, and you can kind of do the math and figure it out. And you probably need to for your project or your product. I think Evans talked about the rel performance model in his presentation a couple months back. But there are a couple of aspects there that really apply to this. And one is the response time. So anytime the user interacts with your application, whether it's a click or whatever the case may be, you should respond within 50 milliseconds. And basic content should be loaded within 5, right? So I'll let you guys do all the math on what to meet these type of performance metrics plus this chart here, right? You're gonna have to do some tricks and some things like that. That make sense? Questions or comments? And finally, some places just have finite amount of bandwidth available, right? There's the cost and there's the speed, but there's also limits. That's pretty much like everywhere. Even in the US, we have plans that have very limited amount of bandwidth available. And in some places throughout the world, that's all they have available. Okay. So there's not, like when we're developing apps and websites, there's a number of things that we're always having to consider, right? It can be overwhelming sometimes. And the fact of the matter is, bandwidth is never the most important factor to consider. If it was, we just wouldn't build products, right? So everything I'm presenting here needs to be kind of weighed in with other things that are also very important, sometimes more important. Like the requirements of the product, it exists for a reason, right? It's gonna have some payload requirement. Providing the user experience around that. So if you create something to do something, but you're not doing it well, right? You're not actually achieving the goal of having this product. So having a good user experience is going to take some payload. It's kind of counterintuitive, but to meet some of those performance metrics, particularly around perceived performance, is actually going to potentially require more payload, right? So you want to pretend like you're doing something within 50 milliseconds. That's gonna cost a little bit of payload, right? There's budget limitations. So if you handcrafted every single view, hopefully you would see that that's lower payload, but that would be extremely high in production costs, right? So Something to balance with all that. Using stable, mature, reusable code oftentimes comes with a higher payload associated with it. It's solving all the problems, right? And we typically want to use stable, mature, reusable code. Talk about long-term maintainability, right? Using common patterns, libraries, frameworks often age better than handcrafted one-offs, honestly. Talk about SEO, server-side rendering. Markup always weighs more than data for the most part, right? You're going to pay for that. Adding full-on accessibility access to all your features. It's going to take some payload to do that. Deadlines, we don't deal with that here, right? Like, it's never the most important thing. It can take time to optimize. You need time to do it, like, from the product side of the house. So there's sometimes brand or legal compliance that requires larger payloads. There's more, right? And so the gist is, don't worry about all the things, and also don't use bandwidth as an excuse not to do things that need to be done, right? There's a lot of things that need to be done. There's a lot of trade-offs that we have to juggle. Fortunately for us, for the most part on the technical side, we educate, we inform, we advise, we say, here's the consequences of making this choice. And it's up to the product developers and managers to really weigh those trade-offs, to kind of do all that kind of stuff, worry about that, and really kind of take the consequences of that. So that's a good thing, I think. All right, so let's talk about understanding, right? I have a pop quiz for you. True or false? Being bandwidth friendly is simple. Just send down less data. Raise your hand if you think that's true. Thank you. False. You get like literally one person raise their hand entirely. All right. It's kind of true. I mean, it's not simple. I think that's the gist, right? So there's a number of things that actually makes this more complex. So for the sake of this column of slides, right, let's just define an interaction as some user-initiated event which causes the view to update in some meaningful way. Like traditionally, that's been navigating URLs, right? When you do that, that causes the whole UI to change. But there are other things like opening a drawer or a menu. Scrolling vertically causes more content to appear, right? I mean, it's kind of there, maybe, and they just can't see it, right? So changing tabs, like think about a tab, like something with like tabs that they're switching between tabs, that causes change. As you paginate through result sets, cycling through a carousel, opening a modal, there's a number of interactions that can cause a significant change in the view, okay? And with that in mind, you look at something like this flow. You're starting on view 1, there's no scrolling, there's just an input, right? You submit that. You end on view 2, there's just a big thank you. There's not a lot of room to optimize here, right? There's like one interaction. So your strategy here is basically don't mess up, right? Just don't do stupid things. And that's, we'll talk about that in a minute, what that means. Right, but then we look maybe at a view that looks like this, right? It's like a complex landing page. And along the top, we have like 10 slides. Each slide has an image and maybe some call to action. And as we scroll down, we can scroll vertically, right? More content's appearing and we get more images. And at the bottom, maybe we have a third-party commenting system, right? Like Discuss or something. And there's some, you click here, you can view the comments, you can write a message in maybe rich text format, hit submit, you submit a comment, right? So in here, there's a lot of room to optimize, right? You still don't want to mess up, that's always bad, but you can optimize assets, tailor the device capabilities, and lazy load kind of the more expensive parts. We'll talk about what that means exactly. So here's my best bad analogy, okay? So on the left-hand side is a non-evil Ouija board, okay? And kind of think about like the viewport, right? Like the whole board is your content, your whole entire domain. Like no one ever looks all of it at once, right? They're always looking through bits and pieces of it through this little viewport. And that viewport is of various sizes, right? And that board is so big that no one can probably even measure the entire like weight of the whole entire board. And the users can move that thing in any direction, all right? So kind of as your users interact with your application, your site, it's kind of that same idea. There's a ton of things that they can navigate through, but they never do it all at once. And in reality, they never do it all, right? No one ever visits everything in your site or your app. That makes sense? And if you're sending down data for those features they don't use, that's bloat. That could be other pages. That could be slide 10 on your carousel. That could be anything. There's a number of ways to consider that code or content or data you send down for things that they don't ever actually look at is bloat. So this is also sometimes counterintuitive. Sometimes we will add more code, more markup, more whatever the case may be, that it does increase your app's potential payload, right? Like if they download the whole entire thing, it's bigger now, but they don't do that. You put it in there to smartly load content or to defer or to be lazy or whatever you want to do, right? You effectively reduce the payload. Does that make sense? So it's not as simple as just send down less, right? I mean, it kind of is, but not really. It's not simple, I guess. So basically, sometimes you add more to send less, right? So back to the whole point of the slide. What to understand is really the expensive parts, right? If you're looking to optimize, right? Find the things that are not optimized. That includes your assets. We'll talk about that. Sometimes just to meet the deadlines, we quickly add a library. Don't really consider what that's doing, right? I understand that. Media is always very, very expensive, right? Fonts can be surprisingly expensive. And third-party integrations or libraries or frameworks, you got to be careful there. And then just things, sometimes just the nature of the UI or the thing that you're providing is expensive. And so these are things to look out for. This is where you probably, if you're looking to find the low-hanging fruit, find these things, make sure they're optimized, right? And we'll talk more in depth about that. But in addition to that, you want to kind of understand the nature of your app and its features. Like understand the different pathways people can take. And weigh that against the expensive parts, right? So carousel is a great example. 10 slides, each with an image, pretty big image. I mean, that's a lot. That's a lot of things you could potentially be sitting down, right? Understand that. Figure out how to optimize around that. Typically when an app is developed or a site is developed, hopefully it's done so in a strategic way that you're trying to kind of herd traffic in a certain direction, optimize that path, right? And then once that's built, really understand the user behavior. See if it's actually playing out that way. Figure out how, for the bulk of the people, you can actually end up sending down less. Does that make sense? So bandwidth-friendly, I say, is about minimizing the payload, using various strategies to postpone, tailor, or avoid sending down data to end users, right? And it's really kind of two categories. One is don't mess up. There's just some kind of fundamentals that we should be doing. And then on top of that, if you can get the time, if you can make it a priority, right, you optimize. And we'll talk about that. All right, so let's talk about budgeting. I don't mean money, I mean like a bandwidth budget, right? If you don't have one, you have no way of defining whether or not it's good or bad. That makes sense? How do you know you're doing good or bad if you have no context? So define what the budget is. So this is what we're targeting. Then you can actually measure against that. So I think before you begin anything, you have to have some sort of definition of what good means to see if you're achieving that. And this is going to vary, just like we talked about all those trade-offs, right? So you got to count all those trade-offs, all the goals of the application, what you're doing, and based on that, these numbers are going to change, right? But for me, when starting out of the gate, I look at this. This is kind of a baseline. If on a per URL basis you can send down less than 500K, you're probably in really, really good shape, right? 750, yeah, you're kind of like, I'm going to keep my eye on that. You approach 1 meg, I hope you understand what that is doing and it's worth it, right? And then more than that, I don't know, makes me uncomfortable. Each product, it depends on your demographic, your target people, where they're at, all that kind of stuff. It can make this go probably up as far as the limits go, but maybe in some context down. Does that make sense? So have a budget. And not just by URL. Do it by kind of like asset type, right? So let's talk about like 30K. 30K photo is amazing. Like it's probably never going to happen. That's how amazing it is, right? A 30K platform framework is good. That's reasonable. That's jQuery. That's React. That's Angular. That's a number of things kind of along in that kind of range, right? 30K font, I'm starting to question a little bit whether or not that's good, right? 30K like date formatting library, right? That's probably like you're going to have a hard time staying under your URL budget if you start doing that. And then, you have a 30K icon. I'm sorry, I can't help you. But make this budget a product requirement, right? That means getting the whole team on board, not the whole dev team. Getting designers on board, product development on. Let them know this is important. Try to make this part of the process, right? Because if you don't, they're not going to value it, and they're going to be sending requests or feature things that completely is going to destroy this. So you have to get them on board. All right, let's talk about measuring. Okay. So probably the easiest thing to do. I don't know everyone who's not familiar with the network tab. I don't want to call you out, I guess. In your dev tools, right? I'll just show you real quick. Your Chrome dev tools. There's this network tab. If we were on a different thing, that's what I didn't want to happen. Let's go to like LDS.org. So over the right-hand side, this is probably the best way to just kind of get a rough idea of things, right? You go on your network tab. There are some things you want to have enabled that will give you more information. One of them is this thing right here. Make sure that box is checked. That's going to tell you more about the request coming down. Pretty much when I'm developing, I always have disable cache checked, right? Or when I really want to measure the worst case scenario, you have to have that checked, right? And then look at this side right here, and you kind of see the effects there, right? For a home page of a site less than a meg, it's pretty good. Honestly, most home pages are going to be like your main home page like your whole entire site's landing page generally is going to be like the most art-directed, media-heavy kind of thing, right? They're generally going to be a little bit bigger. Questions or comments about that? If you're not familiar with this, I would suggest getting familiar with it. You can sort based on the type of request that happened. This will really let you, or filter, up here. It'll let you really get an idea of what's being sent down. You can sort by things, including the size, right? To find the things that are maybe more problematic than others. Yeah.
In the previous slide, you said enable the gzip transfer size. Where's that?
That was that little button I clicked.
Oh, sorry.
You're good. Right. It's this thing right here. Can you see it? Right there. Oh. It's that. And I'll explain what that is, but you'll see right here I have two numbers. I remove that, I only have one. So enable that. That'll give you just kind of more context about the response being sent down. Oh man, I'm gonna go faster. Okay. All right, here's a fun site I like to go to when I'm considering adding an NPM module to a project. It's called Bundlephobia. The URL is down here, cost-of-modules.roquapp.com. You can just type in a node module, and it'll do some building of it and let you know what it's going to cost when it bundles all up. So, for instance, Moment, at least at version 2, 64K. Right? It's probably a little heavy to sit down on the client to format a date. Just saying. Okay, another tool that you can put into your build process is Webpack Bundle Analyzer. There's a link at the bottom. It'll help you identify visually kind of the biggest problem childs, right? So in this case, based on this GIF, it looked like it was, I don't know, Lodash, I think. Bluebird. Like Bluebird is a good example, right? It's a promise library. If you don't have to support really old browsers, you're sending that down for pretty much no reason. Like there's promises built in. There's some editor plugins you can use that will actually let you know when you put an import. This is what I use called import costs. It's for VS Code. I type in something, it tells me what it's going to cost when it's ready to go. Make sense? And if you're really fancy and you have CI set up and you want to make this really a part of your system, there are some tools out there that you can actually make the bundle size a part of your your pipeline, your build pipeline. And again, like if you can make this part of your QA process, that's awesome, right? You're doing awesome. So get everyone on board, including making sure it's being done. All right, so let's talk about how, right? Part one is don't mess up. Probably the fundamentals, okay? Think. I mean, really, that's the biggest one. Like, before adding to your app, ask yourself, do I really need to do this, right? What does it weigh? What does it do to my budget? Can it be optimized? I mean, this will go a long way. All right, part two, let's talk about gzipping the responses back from the server. To server configuration, but basically it'll return the content zipped up if the browser asks for it that way, which most of them do. It works by HTTP headers. Here on the left, you see a request. It says accepted coding gzip, right? Server sent back a response with it gzipped. And here's that tab we talked about before, where these two numbers is after gzip and before gzip. I mean, we saved quite a bit there, right? So a third of the size. So that's pretty. I mean, this is the configuration, right? Like that's pretty amazing. There's a node mod. This is for Express. There's a module called compression. You use it as middleware, and then now you have gzipping. For other things, there's similar processes that I can't help you with. Sorry. All right, cache headers. Let's talk about that. So there's another HTTP header called cache control. It tells the browser how long to consider the content at this URL valid. All right, so the browser can then optimize whether or not it gets it again. You set it as a max age. There's some other things that you can add there. It's in seconds, right? But here's one on the first load. Look down from our network tab of the DevTools, right? The first time with no cache was 849. You know, a subsequent visit to that same URL put it down to 25, right? I mean, that's huge. It's a big savings. So really important to do that. And again, it's not hard, right? Just being aware of it and doing it, having it a part of QA, right? Make sure it's being done. It's basically here's Express again, setting an HTTP header. I'm setting the max age to 7 days, right? Yeah.
In your experience, how good is the browser at knowing whether or not it needs to retrieve it?
Like good enough to where it's not even something I've ever had to even like think about, honestly. So they're all pretty good at that. And for regular end users too, who probably don't have weird dev stuff installed, like it's probably flawless, I would say. Yeah.
So if you have a 7-day thing and then you do a new release after 3 days, so does the browser automatically know, hey, this has changed?
No, so now you're talking about like something called cache busting. And there's a number of things you can do. You can hash your assets and keep a record of all of them on there. You can version them with like a get parameter. Really kind of depends. But the gist is you need to, on another visit later, tell them to look at a different URL. Mm-hmm. That's a good question. All right, let's talk about optimization and minification, right? So here's an example of minifying JavaScript, and a very kind of scaled down so you can kind of see how it works, right? We've created a function called add 5 things. It's really helpful. Takes in 5 parameters. The parameter names that we wrote that up are really, really long, right? Which maybe is good for the next step who needs, some more context about adding 5 things. And it takes all that, right, and runs it. You run it through a minifier. It safely looks for places it can optimize. So it replaces parameter number 1 with A, all right, and so on and so forth. This is a very simplistic example of what it's doing, though. It's looking for safe places to swatch out long variable names. This feature is built in. Oh yeah, go ahead.
How do you balance when I say minify, I mean, you also combine things into like multiple files, or multiple files into one file a lot of times.
Yeah.
We balance architecture practices, good architecture practices, with the minification. For example, in our application, we take all of our core functions and put them in this one file, right? So we can use them across multiple routes or whatever, but that causes potential bloat. So now I've got this giant file, and they must be only using 2 or 3 functions out of on each page, but I kind of still need all that in there.
Sure.
Otherwise, I've got this mess of code.
So if I don't answer this question by the end, let me know. Hopefully, like some of these other things I'll talk about should address that. The gist is code splitting and tree shaking is the short answer. And hopefully that'll explain what that means as we go on. So anyway, the minification of things, it's kind of built into most modern build systems. Webpack with the -p flag, which tells it production, is going to run it through this thing. There's Battlenify, there's Uglify. This is for JavaScript, not just JavaScript though, right? This is for images, SVGs. There's have this for CSS. They have this for HTML. There's a number.
You got a computer. Your computer's about to
Don't. Thank you. Yeah. So pretty much all the assets you're sending on the client, there's probably some tool out there that can optimize them, right, as far as reducing the payload. So here's example one for images, SVGs, for CSS, for just your HTML. Like it can remove excess things, right? And then if you want to know whether or not it's actually working, if you can read the code, then it's not being minified. And if you can't read the code, it might be minified, or there's something else that's a problem. Questions or comments about this? All right, let's go on. All right, so those, I kind of call those the basics, right? Those are things that probably everything, no matter really the shape of what you're building, should do, right? And not doing so, really, you're just missing some really kind of easy, low-hanging fruit. Okay, let's talk about optimizing. This is going to take a little more time, potentially. You might need a budget for this, both monetary, like in this case, or time, right? Let's talk about a CDN. So CDN is a content delivery network. It's kind of where you put static files. CDNs are typically kind of replicated throughout the world so that people can access something close to where they're at. And they're typically on a different domain than the origin. So you go to like lds.org, and you might be pulling down content from edge.ldscdn.org, for instance. Right? And the way this plays into a performance aspect is that when you put common things on there, right? So think about as you're navigating the web, and you're going to pretty much, a large part of the web is probably going to have like React or jQuery or something, right? And if they've put that on a CDN, you increase the likelihood by the time they visit your site, they already have that cached. They don't have to go get it again, right? So that's one benefit of it. The other one, I've never really done like a measurement to see like how much this really matters, honestly, because cookies have a limit. But putting on a different domain than the origin prevents like the HTTP request from sending like headers that would normally be sent to your origin, like cookies and other things. Make sense? But I mean, there's some difference there. I just don't know if it is meaningful. So there's public CDNs available. I'm not sure what policy here is on using them for things. Obviously, don't put like sensitive things on there. But here's a popular one. You can get almost any major front-end library from this CDN. If you link to it, you're really increasing the chances by the time they come to your site, what they're asking for is already in their browser and cached. Right? The more people doing this, the better it actually works. And there, like I said, there is an internal CDN as well. I think you would want to talk, if you're interested in using it, I would talk to ALM team. I think that's probably the good starting point. Yeah.
Are there any cross-origin policies you have to worry about?
Potentially, yeah. So most CDNs will have, I think like fonts and job. Yeah, I think most CDNs will be configured though to be pretty open about it. Yeah. So if done correctly, it should be invisible to you, but technically, I think you have to worry about that. Good question. Other questions or comments?
Is there a reason to use an internal CDN over like an external jQuery CDN?
Only thing I could think of is just a general lack in trust of the internet. I don't know. There might be some sensitive things you want to do up there. There might not, like if it's application specific, if you're not going to benefit from the herd cache kind of thing, then maybe you'd use that. But, if you pull out like kind of main name brand libraries and you reference them from a public CDN, that's probably, like as far as performance goes, that's probably going to be your best option. Can't speak to the other things that would prevent you from doing that.
About internal apps,
Um,
public facing.
Ones that aren't, I think even still, as long as, if your end users that are using your app are not allowed to access the internet, like they're behind a
No,
fi-
they can access the internet. But the app itself is internal use only.
Yeah, I think they still benefit from this. I mean, they probably, when no one's looking, would go to Facebook. So yeah, they would benefit because there'd be a performance hit, and maybe it's not. Well, I mean, they could be on VPN on a string, so they could really benefit from it. Right. All right, let's talk about responsive media. Okay. So the web is different than a lot of other application platforms, right? We build one app and we serve it up to phones and TVs and everything in between, right? We have like device ranges from a width of 400 to, whatever as far as pixels go. So the device widths, they change drastically. And not only that, sometimes to account for that, our designs do as well, right? For example, maybe on like a design spec we get for a particular image, it's full width in one context, it's partial width in another context, and maybe in another one it's not even visible. So these are kind of the things we need to account for, okay? So a lot of variance, and we can really tailor. There's a lot of room for performance gains here, or bandwidth gains here. So for example, this background image, right? At 900 by 1280, it's 828. I won't read them all, but the very lowest one goes down to 42K. Still not that 30 that we talked about earlier, right? But the gist is, like, even the difference between 900, 1900, and 1600 is saving you like 300K. That means something. So images have pictures especially have a very high cost, right? So there's a lot of bandwidth savings to be had by sending the right image for the user's device, okay? And there's three ways we'll talk about that you can do that. So one is CSS, right? This is kind of used for more of the like background image, decorative image, things without semantic meaning, right? And just a background URL with some media queries saying, hey, start with this one. If the screen is bigger than 400 pixels, use this one instead. And if it's bigger than 8, use this one instead. Does that make sense? And you can do that at whatever levels you think make sense. So in addition to responsive CSS, there are a couple HTML things that we can use. One of them, not a lot of people are aware of this, the good old image tag has this thing called source set and sizes, right? And source set takes a comma-separated list of the path to the image plus some descriptor of that image, which is usually it's width, like 800, 600, 400, right? It could also be pixel density, but basically it's a comma-separated list of pretty much the same exact image, usually. So in the case of that background, it would be all of those pictures of that car. It's the same image, just at different aspect ratios, different dimensions, right? So you tell the browser, here are the list of possible images, and you describe them a little bit, and then you tell the browser the context, and you say, hey, if I'm at least 800 pixels, I need an image that fills up 50% of the viewport width, right? Otherwise, it's going to take up the full width. The browser kind of takes those pieces of information and figures out which image to load to kind of optimize that. It's not an exact thing. You're not really prescribing what to use. You're giving hints to the browser saying, hey, here's additional context for you to figure out what image to load that best matches the user's device. And this is great for things where an image has semantic meaning. You need an image tag in the markup because it's for whatever reason, right? There's a lot of reasons you need that. Questions or comments about that?
So it's the browser that makes the decision which one to load.
Mm-hmm. Yep. And in addition to this, There's something called the picture element that's newer-ish, right? And same idea, there's a picture tag, and in there you have some sources and a fallback. You do the same thing. You say, here's the source set, here's the media. You can use this as well. This will do, I think, everything that the source set will do. My impression of this is kind of more for art-directed situations where you're not just chopping up the same image multiple times, but potentially you're even changing the whole entire image out. Like, let's say, from a landscape to a portrait or whatever the case may be, but it's kind of a more art-directed situation. But you could use it for just the other stuff as well. Yeah.
Another difference is this one, as you resize, you'll actually have the other image size. Because it's expecting a different image, a different size.
Yeah.
Source set won't. So if you start on the biggest size and shrink it down, you're just going to stay on the biggest one.
Correct.
This one will get the smaller size because it could be different.
Because it's art-directed.
Yeah.
I think in the other context, if you start small and go big, it will grab another image.
Well, the source set,
Yeah.
image source set will too.
Yeah, that's what I meant.
Yeah.
But yeah, good. Thank you. Any questions or comments about that? So again, like this seems like a kind of extra, but I just want to point out again, like how much of a difference this could make, right? I mean, you're talking anywhere, like 750K difference per image potentially, right? So I mean, there's potentially a huge amount of savings to be had here. And can you use it? Yes, you can. Pretty much everything supports it except for things we don't care about. Yeah. Yep. All right, let's talk about web fonts. The most bandwidth-friendly option is system fonts. But the chances of actually that happening are about 0, right? So I've never really been in a situation where a public-facing particularly, but not even just that, where we're okay just shipping out system fonts. So, but that's going to be the most bandwidth-friendly because you're sending down literally nothing for that. But we're in kind of a more realistic situation, and we have to deal with custom fonts. Okay, you got to be careful here because this adds up fast, right? So for every combination of weight, style, and family, you're potentially increasing the payload, right? So for instance, light, italic, open sans, that's going to be 10 to 40K, right? And if I want normal italic, that's another 10 to 40, and so on and so forth. And there are 9 potential weights, 3 potential styles, and unlimited families, right? So, you know, if you don't watch this, this is gonna bloat fast, right? So best advice is collaborate with the design team on this one. There are trade-offs to be had. Agree, again, create a budget, agree on it, and stick to it. Like, there are things that you got to balance here, and so balance them. Some somewhat good news is that fonts are lazy by default. Here's the definition of a font face. Here we're saying, we're calling it My Helvetica. There's some sources where you can pull that from, including try here locally if you have this installed, right? And then falling back to a remote path. But this particular font won't load until there's another CSS rule along the way that matches, hey, use the font family My Helvetica in a bold context with this Unicode range, right? So you can limit or delay potentially the loading of that font until this context is met. Make sense? I'm gonna go faster. All right, let's talk about cached and offline assets. I think Nate did a donuts on this a few months ago. It's basically talking about the service worker cache API, right? So here's an instance where we're grabbing our main assets and we're caching them, right, using the service worker. There's another donut slide and presentation you can refer to if you want more detail, or the internet. This is from Google, but this is the gist. You can tell it, hey, cache these locally. This will work even when they're no longer connected to the internet. Can you use it? Yeah, pretty much. Right? If you're starting something brand new right now, particularly, probably by the time that ships, we're probably good. We don't care about the other things. So along those same lines, we have this idea of cache data, right? So service worker cache API, very similar. This is also again from Google on the bottom. This is their try cache first, if not, go get it from the network strategy. And it's still using the service worker cache API. And we're saying, hey, when a fetch event happens, respond to that with, do I have this in cache? Yes. Then return it from cache. Otherwise, go get it. It's not a lot of code, but it could make a meaningful difference at some point. You have to worry about like cache and validation, all that fun stuff, but you know, it might be worth it. Questions or comments about those last two slides? They're service workers. Again, we have presentations on that as well. So, all right, let's talk about tailored data. So kind of a very common situation, right? In view one, we have this endpoint we're interacting with. It provides all this information about people, right? But what we actually want in view one, their name, their URL, and their picture. Every other piece of data we're getting is bloat. We're not using it, right? So something in here, I think GraphQL is a really good fit. You model your endpoints in this way, and then you just say, hey, from this, I just want these, right? And it won't send you down all those extra fields. I think we also have a presentation on that you can look at as well. Some awesome features that you may not be aware of. Let's suppose there's another view. This is view 2, and we need some of the same thing we asked for before. But this time we also need like their favorite food. We're looking for someone to have tacos with, I guess, right? And so the endpoint's providing all that. We've already asked for the people. We've got back their name, their profile, all this kind of stuff. But we don't have their favorites. So we can request again and get all that extra stuff, their name and all that, right? But there are GraphQL clients out there that know, hey, you've already asked for this, and you already asked for their name. I have this. I won't ask for that again. So the request going out at that point in time will just ask for their favorite food. It's not going to go get all the data it already has. Does that make sense? So there's some potential, definitely a lot of potential savings here. All right, tree shaking. This was that question from earlier. Tree shaking is also known as dead code elimination. Okay. In JavaScript, if you write your modules with ES6 static import-export modules, right? In our example above, we have math.js, we have a square function and a cube function, and then our at or entry point, right? In a Webpack config, you can define multiple entry points. In this case, we're saying in our at entry point, we need cube, but we don't need square, right? And so the bundle created around this entry point, if done correctly, will actually tree shake or remove that square function from that bundle. This is how you condense, but still not break other things potentially. Multiple entry points, tree shaking. So something like rollup from the very beginning. Rollup is a bundler. It's done a pretty good job at tree shaking. Webpack 2 came out, it kind of sucked at it, honestly. And then in Webpack 4, they made some additions to it that requires a little bit extra work on your part as either a module author or as a consumer. And the gist, it revolves around this configuration item called side effects. And basically what you're doing is you're telling Webpack whether or not it's safe to remove unused things, which you probably want to do. And this could potentially reduce the shipping down a bunch of unused code. Questions, comments about that? Yeah.
Does Webpack actually shape all the libraries you imported as well?
If you don't use them, yeah. So as long as, so the caveat is you have, like, it has to be using this format here. So if they're shipping non-ES modules, I think you still can configure around it. It's going to be extra. But to get it easy, if they're shipping a ESM, a module version of their whatever, then yes, it'll automatically do that. So something like moment could potentially, you can pull in the date formatter and not get all 60K. You can get the 1K. But I would make sure you're measuring, right? Good question. Any other questions, comments? All right, let's talk about being lazy. This is a good thing. So the web always, from the very beginning, was lazy by default, right? We've never ever pulled down, well, never an asterisk, because I'm sure someone did. In a normal context, we've never pulled down the whole entire app or site at once. We've always had these little windowed views into the content, right? In the very beginning, it was just based on that URL, right? And we didn't really have to do anything. We kind of got that. But there was some event that was a URL transition that caused our browser to go get more data, right? So lazy is a good thing. It's kind of the foundation of what we build from. But there's a lot more we can do other than, like, you think about what changes they view in a significant way. It's more than just the route transition. There's a number of things that do that, right? We talked about it at the very beginning. That's like cycling through a carousel. That's even scrolling. These are a number of things that are events that happen that trigger more content to be visible to the user. Okay, so let's talk about lazy content. So we have the idea of below the fold, right, which is like a newspaper term that we decided to hijack. The gist is, in most browsers, when they load up the site, they're probably not going to see anything down here, right? Like these images. How much data have we wasted sending down that where they've never, like, they just click maybe that first thing up top, right? There's a lot of waste there. Or the off-screen content, right? So each of those are an image, a background image, weighing in anywhere up to 800K. If they don't ever cycle through it, that's waste, that's bloat, right? So slides 2 through 10, right? So what if there was only an event for when something enters or exits the viewport, right? Like, that would be awesome. So there is, yay. I think Blake talked about this, I don't know when, a couple weeks ago, last time? I don't remember when it was. But there's a newer feature called Intersection Observer that you can configure, where the gist is you create an observer with some configuration, and it notifies you when content enters or exits the viewport, right? Which is that event hook we want to use to know, hey, the user actually cares about the things below the fold. Let's maybe load the expensive parts, right? So in this particular case, if you look, the observer is a new observer. There are the options, and the callback is some function, an event listener or an event callback to be executed whenever one of those events occur. And if we want to just kind of be real crude about it, we could do something like, hey, I have this stub. When this enters in, load this 3 meg image, right? So that's kind of the gist of the plumbing there. For those in React and GPL context, we have something called Even Lazy. You can do that, you get it free. That's basically the API. It's not a lot of configuration required. You install, import, and use. Question, comments about that? Kind of cool. All right, how about lazy data, right? Go faster. So most component-based systems have this idea of lifecycle methods, when things are shown, removed, different events happening on a component, right? So down in here, we have this comments pane. You click on this. When you do that, you want to view all the comments had by this particular view. Probably don't want it there by default because, maybe you're, like I said, only 5% of the people actually ever do that, right? So you really want to make that lazy. So what you look to do is say, okay, when the component housing that comments tree or view mounts or shows, or there's a birth life cycle of it, right? We're going to actually wait till then to even go get the data for that. So here's an example of a fetch component in React, where the API we're like, hey, when the current pane has comments, mount this component called fetch, render the comments pane when it's done, right? And that component would look something like this. Pretty, not a lot there, but potentially a lot of savings, where when the component did mount, grab the URL, render it. So you just kind of have this thing waiting until the user shows some intent to actually want to interact with it. And when it does, that's when it waits, or that's when it fetches the data for it, which could be a significant amount of data, right? Questions, comments about that? You guys awake? Okay. So we've talked about what lazy content, lazy data. How about lazy code? All right. So let's imagine this down here is using some fancy third-party rich text editor, like Quill.js is a good one, right? It's pretty versatile, but it's also like 50 or 60K, right? So it's pretty heavy, right? So maybe we want to avoid loading all of the data, all the code for the Quill text editor until some event happens, right? In this case, we'll just probably make use of that lazy again because it's there by default. When we've detected they're getting close enough that they probably want it, we'll wait till then to load it, right? So there's a number of systems out there that allow you to do this. In our starter, it's a Next.js starter. It comes with something called dynamic, right? Imagine we're importing that dynamic function and this lazy thing, right? And we're wrapping this import statement, import function around this library here, which gives us a new component, in which what it does is when it mounts, that's when it pulls down the code from the server, right? So until this thing actually renders, which we're attaching to scroll events, we're not going to be pulling down the code for that Quill editor, right? So 60K you saved, right? Or React times 2. So questions or comments about that? Thoughts? Complaints? Anything? The end. I think we're out of time anyway. So yeah, that's the end. Thank you.